How's it, guys? Welcome to my channel. My name is Sal, and my intertwining topics for today will be perspective, motion, and relative motion. So guys, I'm going to be voicing over sunsets, a few clips of Venus, and of the full moon. I would also like you to take note of the lens flares, because although the sun is so blazing and blaring at us, we can see the true size of the sun and exactly how far above the horizon it is. When it comes to the motion of the earth on its own axis and, in its orbit around the sun, I can almost understand how flat earthers may not be able to comprehend it, because the earth rotating on its axis propels the earth in its motion around the sun. And unfortunately for flat earthers, that is happening simultaneously together with some other motions, including the motion of the solar system in its orbit around the galaxy, and the galaxy on its way to the great attractor, and the expansion of space, and so on and so on. So I've taken the example of holding an object, namely a ball, right up to your eyeball, right? What you will see is basically a blur. And when you've got this object up against your eyeball, you cannot decipher what the object is. When you move it a few centimeters away from your eye, you may be able to get a slight indication, but still not the full picture. So holding the ball right up to your eyeball would be akin to you standing directly on the ground. And holding the ball a few centimeters away from your eye is probably akin to you being in an aeroplane. So you have a slight idea of what you're looking at, but you still don't have an indication of the full picture. So when it comes to the motion and direction of the earth, when I first learned in which direction the earth is orbiting the sun, I couldn't wrap my mind around it because of the direction in which the earth is rotating on its own axis. I had to physically stand up and go outside and turn myself in the direction which the earth is rotating, and then propel myself in the direction of the orbit around the sun. I must say it was very difficult for me to understand, but once I did this physical experiment, I was able to grasp it. And watching Venus helped me a lot understand the ecliptic, the plane on which all the objects in our solar system go around the sun. They all go in generally the same direction around the sun. Obviously, some planets are flipped on their sides, or they've been knocked completely around and it looks like they are in a retrograde motion, but those end up actually being upside down. But they all are moving in the general same direction around the sun. So what we have to do is take everything in contemplation according to relative perspective, right? We are here on Earth and we are looking out. So we see the other objects moving in certain patterns. And what we try and figure out is how we are also moving within that pattern. And we can see that we are in motion and how the other objects move relative to our position. And when I say our, I mean the earth. We are on the earth. Also, I have to speak in layman's terms because obviously most of us don't have access to the Hubble telescope or the ISS. We cannot be up there and have that vantage point. So all of our viewing is from Earth's perspective. We have to take everything into consideration from how we are viewing the motions out there from Earth. And then we can also see that together with all of that motion, the Earth is also in motion. One of the things that actually set off this train of thought was flat earthers love to talk about the curve of the Earth and where it starts. The curve of the Earth does not start at the horizon. It starts where you are. Every single one of us, no matter where we are on the Earth, we are standing on the curve. That's why the view starts off at the bottom. Now, what I've done is, because on land we cannot see what I'm about to talk about because of the hills and valleys, flat earthers love to use the ocean and boats going over the curve. So that's the example I'm going to use. Why does the water start at the shoreline and go up the photograph and then there's a sharp cutoff? It's because we are on the curve. That's why I used the ball reference. Every part of the ball is the curve. And now that I say that, I remember being ridiculed when I left this in a comment. But how else do you explain it? Every part of the ball has a curve. So when you are looking for the curve, for example, flat earthers love to say left to right, the curve is in any direction you look. Also, I have been thinking about this for a very long time, but if the Earth were flat, I don't think perspective would work the way it works right now. I think that if we are looking out from our vantage point, the horizon should go down and away from you, not up and then a sharp cutoff. So what I think from my perspective is that perspective is already incorporated into your observation. It doesn't need a separate calculation. If you were on a different planet, perspective, what you are seeing out there relative to that planet would be different to what we see from Earth. So yes, perspective is important, but it's not a separate issue. It isn't separated from your observation and then incorporated into your observation. No, it's one in the same for that observation. Thank you so much for watching. I'll catch you in the next one. Bye.